Did it not do that? I'll ping you in a minute. I just have to go change the settings. So, no worries. Thanks, guys, for coming out to the data engineering meetup. In July, you braved the heat to come here. No, a couple of you biked here.
Ew.
So, like, we definitely, when you say braved the heat, it was in the most literal sense. Ayla's not here, but we're going to go ahead and thank Recursion so much for sponsoring the event, giving us pizza. Give Recursion a round of applause for everything. Ayla was the one doing the name badges at the front. Notice there was, if you drove, which is the most efficient way I've found of getting here, it's not like the most economical or whatever. They do validate parking here. There's a QR code up at the front desk that you can scan, and they will validate if you're in the north parking garage. And that's how it's going to work from now until the gateway changes ownership.
When does that happen?
It happened at some point, I don't know.
In like the 80s.
In the 80s.
Yeah.
So they updated their parking systems. Essentially, they scan your license plate and you pay on the app, and they'll basically, if you scan the QR code, they'll validate it for you. You do have to know your license plate number, which apparently I don't know that, and I don't know how I grew to be 31 without learning how to remember a license plate number. So there's that. By announcements, so announcements will go here first. So I'm going to do Slack, then future meetups, then we'll do jobs. Okay, that way I'll keep track of it. So.
I have an announcement too.
Oh.
We'll do it at the end.
Joe's is last, because Joe's special.
Not in that way.
It used to be his meetup, so he gets special privileges. This meetup is brought to you by the Forge Utah Foundation. Forge Utah Foundation we have a bunch of local tech meetups, all different kinds. Yesterday was the Kubernetes meetup. Next week we have the MLOps meetup. Their title is What is GPT Anyway? There's a Go meetup, a Zig meetup. Tomorrow there's a Colo meetup. If you hate the cloud and you want to put everything in a Colo, there's a meetup for that. Didn't know that. We coordinate almost everything through Slack. Our website is forgeutah.tech. There's a button right on the front. You click Slack, join the local events channel, and you'll hear about all the events in the area. F-O-R-G-E, Forge. Forgeutah.tech. That changed to blue on me. There's a data engineering thing. I said next was future. I wanted to announce that next week we have the MLOps meetup where we're talking about the GPT models. Next month, the data engineering meetup will be at Vivint in Lehigh. I have Brenna Buke from Min.io coming to talk about on-prem lakehouses. I met her at Day-to-Day Tech. Nope, it was Data Council. I get those confused because they're like the same location, but not the same conference. And yeah, last thing is we have jobs. If anybody is hiring and you'd like to announce your job, feel free to raise your hand. That's my coworker Jethro. So I was going to do it. Do you want to speak to it, Jethro? So I know I got up here 2 months ago and said we're hiring data engineers, and then if you applied, you probably got an email that says we're not hiring data engineers because we stopped. But we're doing it again. So Joe famously says you can't have AI without BI.
Well, it used to be the case. That was before.
Joe, I'm trying to have a segue here.
Okay.
So we're hiring. He did say it. I work for School AI, so we build AI tools, and we need a data engineer to come basically build our business intelligence pipelines and all of that stuff. We do need them to be pretty senior relative. They're going to own the whole thing, essentially. And you won't be working with me long term, sorry. I like Go too much, and Go and BI just aren't friends because of DBT. So if you're interested in that, Jethro is actually the product manager of that team. So you can reach out, chat with him, or chat with me. Business intelligence. Anybody else wanna?
I was gonna say, I don't think I've seen that on the jobs channel.
It's because I haven't posted it yet. Oh. You heard it here first.
Oh, in person first in Slack.
Yeah, like we just posted the job rec like a couple days ago, and so I was gonna announce it here, and then I'll post it in Slack after.
Okay.
Go ahead.
Also, if you're a web developer, I was going to pick up a small job with this one guy I know, and then delegate it to someone else for less work. So, if you need a job, you can come talk to me.
Oh, see, we got hiring. Go ahead.
Hey everyone, I'm Brandon. I'm hiring for 2 data engineers and an analytics engineer right now at DBT Labs. So if you're potentially interested in that, we are looking for senior level folks for all 3 of those roles. But let me know and I'll see if I can get it posted on a board.
Yeah, so it's just, our Slack, just reach, for it's our Slack channel, we have a jobs board. It's great. If you can't, just ask me if you have any questions.
Do you know if you guys are like hiring any like entry level?
Not right now.
For someone who just like finished school?
I am not currently right now. Yeah, so. In data, that's always interesting. Okay, I think Joe's turn for an
Is
announcement.
anyone looking?
Oh, is anybody looking for a job?
Newly product management background in software architecture.
Okay. David, you,
Yeah, I'm a full stack, I guess, but I prefer to be back-end Go developer, web, such as life.
David, I'm still looking for a data engineer, analytics engineer type position.
go ahead.
I'm here. I'm looking for data analyst, business analyst, product analyst, financial analyst type of jobs, preferably entry level. I just finished the data analytics boot camp with a Springboard back in May.
Okay, cool. Cool. Okay, now Joe.
Thank you.
Give the floor to Joe.
Oh,
I'm just kidding.
I'll do your talk as well, Lisa.
Thank you.
Unless you want me to.
Go ahead. I think you could probably infer from my slides. Do you want to try it for like 10 minutes?
No, we're good. I have something way cooler to talk about. So there is a low-key happy hour this
Oh,
Friday.
yeah.
In Foothill area, the baggy bar called Black Sheep. If you've been there. So it starts at 5, goes to 7:30-ish, or however long you want to stay there. The low-key happy hour concept is you show up, you buy your own drinks, you buy your own food, you meet other nerds like yourself, and hopefully talk. Or if you're very introverted, don't talk. I don't really care either way. But show up. There is a Luma that you can do, or just show up. Either way.
And
But
you
again,
already posted it on the Forge Slack at least one time, I
yeah, you
believe.
post it on Forge. I'll post another one on
Perfect.
LinkedIn and Forge again.
Yeah.
But if you're looking for a chance to sort of break out of the traditional meetup environment, conference environment, and just hang out, have a beverage of your choice with fellow techies and data and AI people, here's your chance. We'll be doing these every month, I think, as long as we want to.
Yeah,
So,
nobody's
so-
going to stop you.
Well,
So
I know that. So.
Friday, right?
this Friday.
Yeah, the 18th, 5 to 7:30.
I have never gone because I'm lame and I live in Spanish Fork.
It's a bit far. to
Yeah,
go.
I know it's far for a Friday, but everybody that I talk to says like that they've really enjoyed it. They've met good people, and there's a great opportunity to meet a bunch of and talk casually about nerd stuff. Yeah,
Absolutely. So again, show up.
cool.
It's there.
Okay,
Friday.
thanks, Joe. We're going to turn the time over to Lisa. I'll let her introduce herself. She flew out here to talk to us, so give Lisa a nice round of applause and a welcome. So this is, if you want to clip it, you can just clip it then. If not, you can just hold it whatever you want.
Will I amplify too, or do I have to speak up?
You're good.
Okay.
It picks up really good.
Okay. Hi, everybody. I'm excited to give this talk, but I'm also incredibly nervous. It's my first time giving it, and it's super experimental and weird. So we're going to go on this very beautiful journey together and hope that I make sense and I'm not just like this crazy person talking at a crowd. As you can tell from my title, I decided to throw as many like buzzwords as I could in a single title and make it really convoluted, but I'm going to try my best to deliver here. And so we're going to be talking about metadata, mostly in the form of data catalogs and metastores, how they build upon the first, like this current generation of open lakehouse architecture, using technologies like Apache Iceberg, Hoodie, Delta Lake, etc., and how something like a catalog can be used to actually build into MCP and actually feed into like different agents and LLMs and enter an A2A. So that's the entire talk. If you leave, that's kind of the gist. But if you get lost, please refer to that. So a little bit about me. I'm originally from Vancouver, where I joined the Loki, and I actually met Joe there. And then I currently live in San Francisco, where I'm part of several meetups, and I just like hang around in the Bay Area mostly. So if you're ever in town, check out the meetup scene. It's pretty nice. And also, I'm very involved in the open source space, so mostly in the Linux Foundation through LFAI and data, as well as open source data infrastructure through different Apache projects, mostly Apache Gravitino, which I'll be talking about a little bit, and Apache Iceberg. And I'm also very interested as a product manager at my company, which is the original creators of Apache Gravitino, aka Datastrato, around the monetization and sustainability of open source within the general ecosystem. Just as a quick thumbs up before I move on, can everybody see okay? Yeah? Okay, fantastic. Folks in the back.
You're okay. I can move the mic closer to her, but okay, we're good.
Okay, awesome. So I kind of want to start with talking about the general field of data engineering and sort of the problems that it solves, because to me, data engineering has been a really reactive field. We kind of are really always trying to build around the needs of the consumer, and so if those needs change, all of a sudden we have to rebuild everything from scratch for some reason. And I think this is something that's really difficult compared to traditional software engineering, which is very bottom up, right? Like we're not necessarily in control of seeing the future and being able to anticipate some of the needs and how they change. And so the first generation of data engineering, very early on, we focused mostly on operational data, tabular data, and really serving to like very basic analytics needs and workloads. So things like reports, things like that. And it was a very small and controlled group of analysts that we would typically serve to in an organization that would want to work with that data. This is something that was very easy to anticipate the needs of, generally speaking, and we used a lot of proprietary databases, but also just like normal Java-based databases like Postgres, MySQL, even Oracle back in the day, and it was pretty siloed, but it was okay because we didn't really have that many use cases until we decided that we wanted all of the data available all the time, always, for everybody. And this created a really large practice in terms of hoarding as much data as we can and storing it in large distributed systems, and which led to Hadoop and HDFS and Hive Metastore, sort of this very consistent large data stack where we had many different on-prem databases that we would store data onto, also different technologies like Apache Pig, Apache Zookeeper, HBase, MapReduce. And generally speaking, the point of this slide is just kind of to say there was really no other alternatives at the time to HDFS and MapReduce. Like we just kind of used what was out there because it was the only open standard that was available. And that's a very different ecosystem than what we're currently working with right now. And generally speaking, because everybody wanted access to all data all the time, we had to move to data platforms. Now, this isn't like a super standard thing across the board, but generally speaking, it's kind of gold standard practice right now to build out a data platform instead of having these rigid, sometimes fragile, sometimes very hard-coded data pipelines that included a lot of redundancy, a lot of reuse transformations, or things that would be very hard to govern and move. And of course, I think end-to-end data pipelines don't do a great job of actually integrating a lot of like different data sources together, a lot of different data formats, and we're actually moving away from a lot of tabular data and actually working with semi-structured data, unstructured data, streaming data, things like that. Also, we wanted to move away from proprietary formats because it became very hard to build platforms on top of those formats and technologies, and they became very painful. People wanted to self-serve. So it was a very different way to use data and way to access data and consumer needs that then data engineering had to then accommodate for. This birthed what I would call data as a service, not to be confused with the business practice of selling data, but actually expecting that you can send a request to some sort of service and receive data as a result instead of having like a very specific pipeline built around your needs. And so generally speaking, if we think about a service, we maybe think about a server, an API, and some sort of request that you'll get. In this case, a request can be some sort of change to the data that we would expect to be updated. And this is really important because back in these days, there were a lot of issues with ACID compliance, and you would have a lot of locking issues, a lot of orphan processes. And when you're moving to a platform that's built upon services, you're able to control a lot of that logic on the server side, right? So let's say somebody makes a request, you can decide whether or not you want to fulfill that request on the server side, or if there's another conflicting request, you can handle some of that logic a little bit easier. And if you're using something more standardized like REST, which we'll talk about later with REST catalogs, you can make that a little bit more elastic. You can have a little bit more control and obscure that even more from the user. Generally, when using platform technologies, you're able to leverage all of the nice things that normal platforms have, like replication, elasticity, load balancing, and generally speaking, you can also have service level objectives, right? And contracts, like, hey, this data has a guaranteed uptime of this time because it's a service, and I can make a service level agreement. And I can also make a contract there in the form of a data contract that, say, some sort of schema has to match there in order for me to be able to fulfill the request. So that has improved the hygiene overall. So generally speaking, I would say that the evolution of data consumers has changed, and it's not that we're only serving to analytics and only RAGs or LLMs anymore, but we're serving to all of the things that came before it as well, because that's kind of how technology has evolved. And now we're hitting this very weird state of the field where we're being introduced to agents, and we don't really know how agents are going to work with data just yet. And so we don't know how to anticipate those needs, and yet still we're expected to actually serve for agents while still dealing with all the issues from previously. And the thing about RAGs and LLMs, and also I assume agentic systems at some point, is that when dealing with a very complex and real-time system, you're dealing with something new called context windows. And context windows are basically the same as stateful applications. And that's very hard to manage because you're changing those things in real time, and you're actually having to synthesize data in a way that's interpretable. Right? And so we have to be able to make sure that our queries are still valid, that we're able to synthesize information sometimes in real time, because everything is very real time now. We're still able to govern those things, and we're able to continuously update and learn. So it's not linear anymore, it's sort of circular, and it's changing, and it's like very weird, and it's very hard to keep up with. So that kind of introduces the problem scopes that at least I'm seeing right now, where the first wave of data engineering was really reactive to the needs of trying to store large amounts of data in efficient ways, right? And I think HDFS was kind of the winner of that in terms of how do we actually store data in a distributed way? How do we make sure that we can efficiently be able to store them without it costing too much, either on-prem or in sort of a hybrid architecture, as well as then the wave of compute, which was then how do we build engines that are actually powerful enough to process large amounts of distributed data efficiently. This, I would say, Spark is kind of the big wave of like these sort of engines that you'll see here, a lot more that have come after that. But generally speaking, this kind of handoff from MapReduce to Spark created this sort of, I would say, obsession with the most powerful engine that one could possibly have. And that's really cool. But now I would say in the last 2 years, we're actually dealing with access as the issue. And the reason why I say that is because once we moved to open table formats to be more compatible to different engines, we had to figure out how to make that pieces of data more accessible to those engines themselves, right? How do we actually control which engines can access what data, especially if you're working with multiple engines like Trino, Flink, Spark, whatever, et cetera. And this is where the catalog has come back in. So in the last 2 years, we've seen this resurgence of the catalog. Catalog used to be boring. When I used to talk about catalogs, people would roll their eyes like, oh, that's legacy technology. And then it became really sexy again overnight. And all of the big data companies like Snowflake, like Databricks have kind of caught on to this wave. And everybody is obsessed with this thing now called the Iceberg REST catalog, which is really just a metadata spec and implementation. And we'll talk about it a little bit later. But generally speaking, access, making all of that distributed data that's now been kind of wrangled into one, at least ideally, uniform format, whether it's Delta Lake or Iceberg, then accessible to reach those powerful compute engines with the governance in mind. And then I would say we're kind of on the cusp now of trying to solve for context problems. How do we actually serve context, and what does context look like once you have that access problem solved, right? And one of the things that's really interesting about that is that we have 2 examples here in terms of first generation tools that have tried to solve this, which are the Model Context Protocol from Anthropic and the Agent-to-Agent Protocol from Google. And I want to note here that HDFS was open source. Spark was open source. The Iceberg REST catalog is open source. MCP, open source by Anthropic. A2A, developed by Google, open sourced, and now donated to the Linux Foundation. And so there's a trend here that the adoption has to be driven within the open source community in order for it to become an open standard. And then after that is a big question mark in terms of once we have these, all these MCP servers set up, how are we actually going to synthesize that data? Because right now I might have an MCP server for Google Drive and an MCP server for another application, but how do I actually merge that data in real time to create meaning? And I actually think that, and this is kind of taking from Joe, where data modeling will be very, very important in terms of making that work in the future, but I don't know, and I might just be kissing some butt. Yeah, it's because data modeling is very old practice. And so let's talk a little bit about data catalogs. I don't think everybody here is as interested in data catalogs as I am. But if you don't know about data catalogs, they are metadata repositories. Metadata is data about your data. It still looks exactly like data. It just contains some different information. And data catalogs have really come in two generations, I would say. The first generation really driven by a lot of proprietary technologies, except for Data Hub here. And they were used a lot as sort of like documentation and traditional governance tools, really places where organizations could come in and manually enter or describe their data so that we would give some sort of meaning to the data that we would have in our tables. Tools like Atlan, Lation, and Data Hub, I think were really great examples of this, of the need to document the data and be able to understand it rather than just at the physical level. And then there was this other generation of catalogs that kind of existed and in parallel, but a little bit later than that, which was the technical catalogs. And so because catalogs have kind of grown wider and wider in terms of definition, when we think about a technical catalog, we think not necessarily of a human interacting with this catalog and gaining information from it like a business glossary, but instead the engine interacting with that catalog. So this is Hive Metastore, AWS Glue, Unity Catalog, Apache Gravitino, etc. But generally speaking, I actually think that both of these should be merged into one place because it's all just metadata. And if we have normal data lakes, why can't we have metadata lakes, right? I would say that the information that an engine finds useful and the way that we grant access to an engine is also arguably useful to the user itself because that user needs to access the data somehow, and it's also through that engine. And this is something that I think as we move into machines having to interpret and work with data, that we're actually going to have to serve for instead of just humans and then machine, right? The query engine and the analytics person is probably going to be merged at some point, and I'm happy to debate that, but hopefully I change your mind a little bit as we go on. So why the open source data catalog, right? So when we talk about metadata, we want to consider a technology that's very wide because it has to be able to ingest metadata from many different tools. The best widespread example of something like a technical catalog is Hive Metastore, which was used to manage and track HDFS tables. And generally speaking, once you have too many data silos, it's very hard to actually get a very high-level view of what data your organization actually has. And now that we have an open table format, and I would say Iceberg is kind of growing to be the open standard here, I would say Delta Lake is still also widely used, but I would say Iceberg is probably the winner at this point. We're going to have to find an open data catalog that can also serve the need and become the new open standard. And that's sort of the missing piece, because right now there's lots of data catalogs that are on the market that maybe, are able to cater to different engines, but there's nobody that really has 100% coverage, and it's a really tough problem to solve, to be honest. And so let's talk about some of the pieces of metadata that maybe an engine would require in order to do its job. So when we talk about physical metadata, we're talking about the metadata that's associated with where that data is stored in terms of the partition, the physical storage, stuff that really ensures ACID compliance, for instance, that can help remove different locking issues or orphan processes that you might have, things like federated access to that data where that data lives. And the point of this physical metadata layer, which you can see through all these open table formats, which are metadata specs, right? They're all built upon Parquet, which is a format. but generally speaking, these open table formats are actually specs that everybody adheres to, mainly Parquet users. And generally speaking, that is meant to solve the issue of cloud storage between different providers and on-prem so that all the data looks the same no matter where it's stored. And it also provides a really great functionality in terms of time travel, snapshot management, partition management. And this is really great because you can manage it across all of your different sources as long as they're in a given format and your engine knows what to expect and how to operate on these sort of things. The second level of this that I would say is the logical and operational metadata, which we associate with a traditional catalog. But you can see here that I've put all of those Iceberg REST catalog implementations. And this is really important because I think that the logical and operational metadata is what the engine actually uses as well to perform the interactions with the user. So for instance, I'm a user, I want to use Spark to query an Iceberg table that lives XYZ over here. And generally speaking, somewhere along that line, I have to determine whether or not that person actually has access to that data and whether or not that query can actually be done, right? And that's essentially what we call data governance in a nutshell, how we tag that data, how we identify that data, how we discover that data, how we search with data, and how we actually allow those external tools to interface with these table formats and metadata specs that we see here. And this also involves some really cool pieces of data as well, like schema evolution and metrics that you'll have at a higher level, not necessarily just columnar, and being able to build that picture out. And then I would also say, and I'm not as much of an expert at this part, but semantic metadata is also kind of the OG metadata, I would say, when it comes to taxonomy and ontology, creating knowledge graphs and different associations between different pieces of data, actually creating vocabularies. And so once you're able to access the data that you want and be able to maintain some of those tables, you actually still have to give it some sort of business meaning, right? This is something that's really important to be able to link that data at a semantic level so that then you can actually, be able to action on it. And I would say a lot of early, AI ML leveraged a lot of these technologies super well. And I think some of that picture has actually been quite lost over time. And we're going to see a resurgence in some of these terminologies, especially in the technical world as we're solving these problems in data engineering. So I want to take this moment to say that the catalog here is really important because it's that metadata layer for access. And it's the only technology within the stack that actually kind of can touch everything. There's no other technology that can do that within the open data stack, especially if you're working with many different silos. You're going to have to standardize this layer, and you're going to have to facilitate interoperability. And that's done through metadata. It's done in the DevOps stack. It's done in the security stack. Why isn't it done in the data engineering stack? And that's kind of why we're headed towards that place right now. And we need to be able to cover all of these vertical domains in order to actually escape just the data stack itself. So this is something that I think is really important, that the catalog, I never hear anything like a DevOps catalog or a security catalog, to be honest, but I would love for DevOps and security teams to be able to use the metadata stored in the data catalog the same way that data engineers and analysts do. So, okay, what does a next generation data platform look like then? Is it like an active metadata layer and it's just the catalog that does everything and the catalog is everything and the end all be all and we all can go home because we have a great catalog now? I don't necessarily think so. I think active metadata is something that is really exciting because we can think about event triggers and systems that leverage the metadata that comes in and the way that metadata changes in order to obscure as much from the user as we can. But generally speaking, it can power all of these things like recommendation engines, analyses, and orchestration. But that sort of active metadata to me isn't necessarily enough, which is why I am making a very bold claim here that I don't necessarily know if it's hokum or not, so I might be spoon-feeding you something, take it with a grain of salt, that I don't necessarily think that the modern data platform is actually a centralized platform, it's an embedded mesh. And this is not to be confused with data mesh, although I think that it came from the right idea. I think that the way that we're going to see it work is much more seamless. And I'm going to give some examples of what this might look like. So agents, I think from a user perspective, probably would operate the exact same way as a microservice. I make a request, and then I hope that something comes out of that. It does something, right? It just might have some more flexibility to it. It might be more dynamic than a normal service because I guess it's able to do some reasoning. It's able to make decisions, but those decisions and that reasoning is really dependent on the context that we feed it. And so that context and how we serve it and whether or not it can get to the agent is really dependent on like this room, like the data engineers, right? And I don't know if we're able to solve that problem right away. But generally speaking, if we're able to fix that problem, then I think we're kind of golden in a lot of ways because agents will need to scale like normal services will. There's a lot of tools that can do that. So I don't think you can see this super well. It's kind of speckly. It's not like that on my screen, by the way.
That's just the projector.
Oh, okay. Well,
It's not like
thanks,
that on the
projector.
refrigerator.
Okay, cool. So this is a really cool talk from Janakiram, where basically he describes containers that are deployed on Kubernetes and the ways that they can be parallel analogies to what AI agents might be. And one of the reasons why I think this is kind of interesting is because if an agent goes down, we kind of want it to self-heal. We want to be able to manage the resources that agents would use eventually. We want it to be, somewhat unique instances. The only thing that I think is really hard in terms of a barrier to overcome is that when you're deploying a container on Kubernetes, you're able to tear it down and bring it back up, and it's inherently stateless, right? It's very nice that way. That's kind of the benefit. Stateful applications on Kubernetes, kind of a painful thing. And what is an AI agent if not just a bunch of state that's useful? So this is something I think that's going to be really tough and why I don't necessarily think Kubernetes should be the data and control plane that we necessarily think that it will be, but it's kind of in the best running to be, hence why I'm bringing back the catalog to this conversation. And there needs to be some tighter integration there between the cloud native stack and the Kubernetes stack. And this is where things get really like woo-wah in terms of like, Lisa, are these ideas really that cool? So I want to bring up this idea of a second brain. I mentioned data platforming and what that might become, but generally speaking, most of the code that we work with today, most of the pipelines that we work with, most of the platforms use very hard logic, right? And that makes sense. We're coders. Of course, the logic is very hard. But if we can shift to a dynamic and responsive system, we're actually able to reflect what a real person with real thinking skills look like. And I'm going to preface this by saying my actual original degree is not in computer science, it's in psychology and neuroscience. So when I think about the way that the brain makes decisions, I think, hey, it's recruiting different parts of the brain that are specialized for that function. It's not like, okay, I'm going to go do a social activity, only the social part of my brain is active. Because that's kind of how a data pipeline works and a data silo works, which is not super cool because that's actually really wasteful and it doesn't recruit the different processes that are actually specialized for this sort of thing as we move forward. And so this is something that I think the brain organically is very good at, is synthesizing data, but we, technologically speaking, have not necessarily been able to accomplish. I don't want to confuse this with neural networks, which were the original AI wave in terms of the way that neurons propagate. This is just the very high level. How do we recruit things at this sort of very high systemic level? And how do we actually create really deep context windows and associations that are built into a system that are reactive in the way that we want them to be? So if we take a normal data platform, we have many different components here with all of these different tools, right? We have our metrics, we have our modeling layer, we have our workflow managers, and all of these are incredibly complex to manage. I would say that it's incredibly fragile if you're at least just starting out, but they can be really fragile and they're very slow to respond to new needs of consumers. That's something that I think is really important. And if we just magically made a brain that had specialized on functions on top of that, we're probably able to do a lot more in terms of creating really cool things within our organization than maybe we had previously assumed. This is where I kind of push my company stuff, so get ready. I work on a project called Apache Gravitino, and Gravitino is very simple on its face. It's a data catalog that can inherit from other data catalogs and use a federated model. So if you make a change in Gravitino, it can make a change to the underlying catalog system. That's it. easy peasy, ready to go, right? And it's really cool because it can support many different types of data, right? Not just tabular data, not just Apache Iceberg, but also your Kafka topics, also your unstructured data, and your machine learning models. This is a really cool idea, and it can serve it in a way that's friendly to most data engineering tools. If you take a layer like this, and you actually use it to power what could be the second brain, again, a little woo-wah, stay with me here, I promise there's some payoff. Can we then create specialized agents or AI tools that can then be agnostic to the technologies underneath them, make the intelligent decision in terms of what to use, and then use that context to be able to action upon that metadata layer / catalog, right? This is a really weird thing to think about, but it actually kind of makes sense because we're no longer moving from a linear point-to-point system. Instead, we're creating intelligent things that can use the tools that are right for the job, and no matter what the tools change, we still keep that context, right? We still keep that information that's really useful, so it doesn't matter if it's Flink or Spark streaming or whatever new engine. If we migrate to the new engine, maybe that agent still has the context of what it used Flink and what it used Spark streaming for. And that's really cool to think about because then we don't have to retrain it and it can make really cool real-time decisions. This is really hard to see, and I'm very sorry about that. I swear my eyes saw it a lot better when I tried it on the projector I was on before. So Gravitino, I said, was a catalog of catalogs model, and you can see my mouse here, which is very nice. You can see that the metadata lake model is here, and you have these different catalogs that it inherits and manages underneath it, and then you have its meta store on the side here, right? And you have all these different sources underneath it. So what if we took this model and we embedded different policies within each layer, and we also added a different action framework where we're able to create different events based off actions that you use to manage within the catalog and metadata lake, and then that could trigger another action, for instance. And that can create a nice little system where you'll have something called an action framework where, let's say, I'm managing a bunch of iceberg tables, and I'm kind of a little bit dumb. Don't tell people this, but I used it for streaming use case. So I had a bunch of small iceberg tables as a result. And then I needed to compact all those iceberg tables because guess what? Everybody decided overnight that iceberg was a streaming technology. And then I needed to do that action. But I only want that to take place after I've hit a certain number of tables or I have some sort of metric in there. So I have some policy defined there. And then it triggers some sort of compaction action and then some sort of clustering action after that, right? And then I can do whatever I want as a result. So that's something that sounds actually kind of useful, right, in a real world context. And so if I think about building this in an agentic way, especially working with LLMs, what if I had different agents that could talk to each other using whatever protocol, let's use A2A, that were able to pull context from MCP, but instead of having these different MCP servers kind of going to different sources and managing 3,000 MCP servers, because that kind of sounds like a nightmare, I just had it attached to a single metadata repository that could store and manage context, and then I used it to actually trigger some different actions and to do some really intelligent things with different decision-making capabilities. And I had them for different use cases, right? This is something that I really like the idea of. So let's say I took my bearded self in a previous life, and I decided to create a data pipeline. So I'm not going to lie, investigating the different source requirements for a data pipeline that I wanted to build, exploring it, building the pipeline, modeling it, building the different transformations, deciding to generate a DAG and submitting it to Airflow, and then running it. I don't know about you guys, but that would probably take me at least a couple days, right? And that's if I really knew what I was doing. For some folks, maybe a couple hours, but you really kind of have to know, and that's one transformation at the most, and it's on a 10-row table. What if I changed this to use a different type of architecture that wasn't even really a platform? What if I had some sort of second brain? I'm going to roll with this term because I don't know a better one. And I was able to send that request in, and it was able to recruit the relevant agents that it needed. So I wouldn't be prescribing it. And then those agents would be able to have the context to create some of those actions, and they could talk to each other, and then they could actually generate the DAG and run it for me. And I just had to feed it the requirements. Who thinks that's possible?
I think everything's possible.
Okay, well, let's see. So this is a demo of Apache Gravitino. This is the community version, that's why it's ugly. If you want pretty, pay for enterprise. And we have many different catalogs that we manage here, right? We have our Iceberg catalog, our SQL GDBC catalog. We have a Postgres database here with HR information and sales information that's stored with Hive Metastore as the catalog. And this is Goose. And it's running a Claude model under the hood. So Goose is just another chat interface that you can use. If you use Claude directly, you can use that. And hopefully people can read this, but I'm going to read it out loud. I give it a prompt, and I say, hey, you're a data engineer. You have this requirement to sell, or like to tell me the top 10 sold products, blah, 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 like normal analytic stuff. And I give it some instructions. I want you to analyze the table in the sales department and understand the relationships between the tables. I want you to validate the data quality and create a summary of that data quality. And then I want you to implement some medallion architecture, build a pipeline that uses the schemas that you find. And then I want you to build the pipeline. And I want you to actually be able to do some sort of data cleaning, create an Airflow DAG, and then summarize and generate a report. And so I want to go back here and show that these are the catalogs that are vanilla. We're going to see this change because, spoiler alert, it does the thing. And so let's move forward in real time. And I'm going to assume that nobody has anything better to do tonight because I kind of want to show you the full version.
We came here, so we have nothing better to do.
That's what I like to hear. So let's continue working on this. So it's analyzing the tables in the sales department now from what is backed by the Gravitino MCP server, which I will talk about in a little bit. And then it's going to gather some of this information. It's going to get the schema information and understand some of the relationships. So it's going to analyze some of the keys that it's seeing, things like that. So you can see some of the output here. If you need to come closer, you're more than welcome to as well. And then it's going to analyze the relationship between the tables, going to see how the columns that it's going to map to. So you can see pretty standard stuff. I'm sure this data, like sales data, customer data, stuff like that. That's stuff that we've all probably worked with at some point. Generally speaking, that's data that's pretty common. And then we're going to validate that data quality and run some queries here. You can see that it's executing some SQL. And there's an output that we've truncated. And it actually found some data quality issues because it's data. And it was able to spot some incongruencies, some orphaned records, some duplicate records, things like that. And now it's going to, again, continue with some of this. We could technically go faster, but I want you guys to see this in real time because I think that's what makes it really cool. And then it's going to build out our data warehouse with our 3 different layers related to medallion architecture. So our bronze, silver, and gold. And so it's going to create the raw data layer now. It's going to ingest some of that data. Then we're going to, again, continue here. It's taking a good bit of data from many different sources, apparently. And then it's going to clean and deduplicate that data. And again, you can check out these different SQL queries that it sends out. And then it's going to aggregate the data for analytics purposes. And again, we gave it pretty vague prompts, actually. Like I've had, yeah. Most of the JIRA tickets I have gotten in the past have been way more detailed than that, and we did not feed it that at all. Then it's going to actually implement the pipeline. And so we can see that's taking data from Iceberg, from these different layers. And let's see what it does now. Continue, continue, continue. Goose is a cool tool. Oh, by the way, it doesn't get enough love.
I have a question.
Yeah.
So, if I may, is this bad time?
I would prefer questions at the end if possible.
Sorry.
You're more than welcome to write them down, though. Thanks. And then we're going to clean this data. I'm going to skip a little bit ahead here for the sake of time and because I want to hear this guy's question eventually. And then we're going to generate and calculate our top 10 products that we wanted. And by we, the LLM, I really didn't do anything here. And then we're going to see that here we're going to check whether or not the data was actually generated in our Iceberg catalog. And we can see that they are generated and that they all have the columns that we would expect. Now we're going to skip forward and we're going to generate an Airflow DAG. Oh my gosh, that's kind of scary. Airflow was a learning curve for me. And we're going to see that it actually does generate a DAG, which is really cool. Whether or not you want to use it straight out of the box is really up to you. Whether or not you want to tell it to refine on certain things, that's up to you. Again, I wouldn't use these unsupervised. I think that this is very POC stuff right now. But generally speaking, it actually does generate DAG in the structure that we would expect to, because Airflow is a pretty widely documented framework. And so we're going to move forward here. And you can see that it's writing some Python code for us to be able to get this data and to move it. And then it's going to give us a summary of everything that it's done. And we're able to get some of the very simple key results out of this that, let's be honest, is the only thing the stakeholder cared about and none of the fancy stuff that happened at the beginning. And we're able to do that pretty quickly. If we take another example of this that can be done in the catalog level, that might be more useful for folks on the business catalog side, we might take a data stewards function, and we might personally want to identify some metadata, apply different policies and tags as it relates to some sort of legal compliance, and we can recycle these agents. That's what I want to use. I want to recycle these agents like we recycle services. And again, agents, I think, are just dynamic services. They're not that scary, I think. Let's see how it does. I'm going to move through this kind of quickly, because I think we kind of get the gist. We know what Gravitino looks like. We have HR data, scary HR data with personal employee information. Oh, we're going to Goose now, which is running Claude and is connected to the Gravitino MCP server. We're going to give it information. That's, again, a little bit purposely vague. So the first thing that I tell it is to find which sensitive columns are in violation of GDPR law, and then tag those columns, query the sensitive columns with the data masked, and then generate a report. Again, I don't tell it to generate anything useful. Like, what is a report even? Who knows? But let's see how it does. And so we can see here that it's going to do some data discovery. It's going to use the catalog to discover this data, because that's what a catalog is for. And then we're going to analyze some of the column structures that we see. So this is some of the logical, operational metadata that we'll see utilized here that we talked about before. And then we're going to apply some semantic reasoning in terms of figuring out which ones are in violation of GDPR compliance. And the reason why we use GDPR compliance here is because it's pretty well known what GDPR is. I could feed it something a little bit more specific, ideally, but I kind of kept it vague on purpose. And then we're going to give tags to this. And because it's a machine and not a human, I'm hoping that it gives it tags that actually make sense and we don't run into issues later on. And so we can see that there's some information here. And that it's going to be applying the tags PII, high, and HR. And so if I move forward a little bit more, again, we don't need to go through every single column. Let's see. We're going to see if it can query the data with the masking in place. So if we query it as is, nothing masked, but if we query again with sensitive columns, we can see that everything was I guess, masked, and we weren't able to see it. So darn, thwarted again. I wanted to catch that person's address, unfortunately. And we can see that it, again, queries, and yeah, it does the thing, right? Like, that's kind of the point. It may do it at a very POC level, but it actually did the thing, which is kind of crazy. And so why is metadata so important to all of this? Well, again, the metadata is where all of that useful information is for context, right? And I think it points machines and humans in the right direction in order to make intelligent decisions based on vague sort of prompts. And this is really important because we can control the catalog as engineers in ways that we can't necessarily control AI or agents. Ideally, I'd like to get to that place, but we can't really do that right now. And that's why I think Gravitino is a really key part in this. If you scan this, you'll go to our GitHub repo, so not even like a sales page. But generally speaking, Gravitino has kind of been built with this use case in mind, and it's under Apache 2.0, so fork it, remix it, implement it, do whatever you want with it. But again, if you want to pay for it, you get a nicer UI and maybe some more cool features on top of that. We can talk about that eventually. And some of the ideas behind Gravitino is really originating to create a single control plane for your, not just your data assets and your data lake, but also your generative AI assets on top of that, with security in mind. Virtualize that data using the metadata so that you're able to save some money in terms of processing, and you're able to connect to data in remote regions that maybe are not necessarily meant to be moved. And of course, it's meant to be cloud agnostic. So it supports AWS, GCP, Azure, all on-prem, of course, and then open source. And so this is our MCP server that's utilized. So you saw some of that in action in terms of the DataOps functionality. Can't do everything, but it can do some cool things. And if you scan that QR code, you'll go to a blog post that outlines the MCP server that is utilized here. So most MCP servers are very point-to-point, like they're one technology and one application. And if you're building an MCP server to a catalog or a meta store, that's, I think, kind of all you need. You don't really need that much more. And ideally, you're registering everything in the catalog anyways. I want to take this time to also note some really interesting things that I personally find as barriers to adoption in enterprise and in like really large scale contexts, because I think this stuff is really fun, but we all think, okay, what about in production, right? Like, is this actually useful? Because we see so many cool AI tools that come through. So this is like field talk between you and me. Specifications are really important. Data engineering, for some reason, has had a really hard time agreeing on specs and adopting specs. I don't know why that is, but that's just kind of been the case. Many other fields are very good at it, but just not data people, and I think AI people are probably even worse at it. So we'll see how MCP and A2A does, but generally speaking, specifications are kind of the key to interoperability between tools, no matter who or what it looks like. And this is something that's really important if we want to be able to create like a unified layer for everything to be connected to. And once you kind of have these systems connected, I think events are going to be incredibly important in terms of like the way that we produce and consume events in terms of action systems. It's not necessarily going to just be only Kafka anymore. I think that the different types of events and jobs and action items that we'll see from triggers are going to be really interesting in terms of how we dynamically interact with these events as well, and events as context in real time. That's kind of weird. But I also think that agents, just like engines, just like any other data tool, should also be held to ACID principles. If I'm an engine and I'm doing a commit on some sort of table, I ideally want some sort of ACID compliance in there. But I can totally see two agents being deployed at the same time. One locks the database to another, and then we're just dealing with Hive Metastore all over again. Like, that's literally just the same repeat. So let's learn our lesson, and let's not do that. Let's not create a bunch of expensive orphan processes, a bunch of dead agents kind of lying, using up resources and things like that, and that are very unstable. Let's learn from the platform engineers and the DevOps guys how to properly do this, and re-bring up our old lessons as well. And also, I think SBOMs are going to be really important. So SBOMs used a lot in security, and DevOps is a software bill of materials. It's basically a list of all of the different software assets used in a particular tool or in a particular system. Again, Data hasn't really done this for some reason, even though it's really important. And so if we're able to create SBOMs that can accompany different tools that we use, whether or not it's an agent or an LLM, RAG framework, whatever, query engine, like report, whatever we do, I think it's going to help us really gain a lot of legal compliance and trust within enterprise systems, right? This is something that should be automatically generated. Maybe one day there will be an agent that does SBOMs for us, and then I don't have to do it. And open source is key. I'm very unapologetically a big fan of open source. Never have really loved proprietary softwares. And I think that we're noticing that eventually anything that's open will become the standard, and everybody will have to eventually adhere to it. I think the Iceberg Rust catalog is something like this. I talked to a lot of different data vendors or tool vendors, and they all have had to adopt Iceberg, and nobody trusts their Iceberg compatibility because they started from the proprietary camp. And I think that's kind of valid, right? Like, you weren't on open source before, why are you on open source now? Oh, because it's convenient and nobody will use you if you don't. So yeah, takeaways. again, we're going through this reactionary thing where data engineers have to redefine their worth and self-value because the goalposts keep shifting and we're kind of being abused as engineers. And now we're being asked to replace ourselves. Metadata should be a first-class citizen more than actual data because I think that it's the key to so many things. These API standards that we're seeing through MCP and A2A are the beginning to a very long journey that we're all going to go through together that may end in Skynet. Who knows? I can't promise anything. And then building without an actual real business use case is a terrible idea. And that's something that unfortunately we are so plagued with right now in terms of the different tools out there. And that's why I wanted to show you a real use case, because even if it's not something you're interested in, at least it's something that you can see somebody else using, right? Okay, thank you. And we can take questions.
So I've been using LLMs for essentially like automating a team of lexicographers, which are people who are employed to like compile dictionary data sets. And my experience as someone who's like been in the trenches is that this whole field can be like a huge mess. Like my philosophy has been if it can fail, it will fail. You need like validation checks throughout. Like I use JSON schemas, for instance, wherever I can, especially like the passes schema validation. That's a pretty good sanity check most of the time. But also, like OpenAI, they say that some of their models, they'll guarantee like valid JSON output if you turn on a relevant flag. But even then, that itself fails all the time. Like you can't expect anything to. So I'm just kind of curious, like, I don't know, someone who's like lost a lot of sleep over this, like,
Yeah.
what's that? How you handle that aspect?
So I want to go back here. And first of all, I want to say that I have those exact same concerns because I think that they're very real. This is, can I edit this? I don't think I can. So I don't know if you guys can see this. This is so small in the corner. But this is the modular monolith microservices infamous chart where there's two places that you don't want to be, which is the distributed monolith, which is where you have a mess of microservices, you have a big ball of mud, and you have normal microservices that are well maintained, and then the monolith, which is modular services that you can contain in some sort of way. And I completely agree. I think that generally speaking, one of the really big issues we have in this field is that data infrastructure is slow to evolve and move, and R&D happens at the AI level. And so,
What's interesting too is like LLMs, they can be like frustratingly like non-deterministic when you don't want that.
Yeah.
But then like if it fails, you might want to just try to rerun it. And then in that case, it can be like frustratingly like deterministic.
Yeah.
Like, I don't know.
No, I think that that's super valid as well. And generally speaking, the only way that we really overcome this issue is by, again, talking to people outside of our field. Bring a DevOps team, bring a DataOps team in, tell them, hey, I want to deploy this agent or I want to deploy this service that utilizes this LLM. How can we actually implement GitOps into this? How can we actually save our config files in a way that's traceable? How can we actually separate all of our different environments so that we're working in development versus just straight into production? Because a lot of that hygiene that software has kind of implemented throughout the years has not carried over into the R&D style of AI development. And that's really important. One thing that I would also say is I'm part of the Continuous Delivery Foundation, which is, saying this sounds so legacy, but I think it gives some sort of credit, which is the foundation that's in charge of like managing Jenkins and Tecton and Argo CD. And we run in that foundation something called the DataOps Initiative. And that's like a vendor neutral forum where literally we talk about these things. One of the like recent meetings that we had was literally an evaluation of MCP, which makes unnecessary third-party calls, is not super maintainable, and is not a real service and has really weird API compatibility with literally anything else. And those are the questions that we need to ask early on, right? So would recommend, like, you're on the right track. You just have to keep advocating because I think that this is a really hard problem to get people to walk backwards to do things right.
Just communicating between agents, like that medium itself
Yeah.
is fail, as I mentioned.
Absolutely, yeah.
And like they're like in my case, like I deploy like tons of heuristics throughout, just to accommodate the multitude of errors like as they happen.
Yeah.
Like I'm also generating like tons of data, and I'll frequently like iterate on the pipeline in such a way that might like invalidate whole swaths of data. So like maybe I've like made more LLM invocations than most people. I don't know.
I mean, maybe, but I also think that that's the right way to do it. especially early stage, right? So, yeah, we're in uncharted
I just,
territory.
I do a lot of app dev work.
Yeah.
I also do like a lot of like automation for very tedious things, like
Yeah.
populating data sets for such.
Yeah. Hi. Yeah.
Oh, yeah. So this is going to be more of a personal question, but you meant earlier in the presentation you indicated that you got a degree in psychology. What made you, how did you come to find out about Gravitino and, or actually like how did you get your feet wet in data engineering?
Yeah, I think I have done a couple podcasts on this. If you Google me, or if you reach out to me, I'll send them to you. But essentially, I used to work, this might feel familiar, with a bunch of people who didn't understand data, but needed to use data, aka research. And so I just kind of became the point person. I was an R developer initially. And then I think eventually I just broke into actually being like a normal data person. I wouldn't say I'm well into my career, but I'm pretty mid-level at this point, so it's not like just from university to this. It definitely takes some time and some years and some practice, but if you really want to get involved, open source, I met the creators of Gravitino through the open source community at the Linux Foundation meetups, and that's sort of how we managed to meet each other, and I would recommend that if you're early. Yeah. Hi. Oh, yeah. Do you want to wrap up and then I'll...
Yeah, I was going to say, just given that, like especially for someone who just completed the data analytics with like,
Yeah.
What you had to say for someone like me who's kind of like a newbie.
Yeah. I would say contribute to open source. Like I made my name through developing an R package, and it wasn't a fancy R package. It was just something that was useful. Under the hood, it was just a bunch of YAML, to be honest, but people used it, and that's good enough. Yeah.
So the data catalog has been used more of data dictionary to find the attributes or elements we were looking for. Do you see that catalog, or like how we define the attributes inside the catalog, should change in order to work with elements, to whatever the video is showing? Now that we really understand the parameter and the vision framework, the different data models across the different storages, does the catalog also need to evolve and be more descriptive, or are there anything key factors you can suggest where we look for or make sure those exist in the catalog so that anyone can really understand it?
Yeah, I think that's a great question. For those of you who didn't hear or maybe online, the question was around whether or not the catalog should extend into also the semantic and business catalog layer. And I think that there's a lot of confusion around the term meta store and catalog and things like that. Generally speaking, from what I've seen, and I'm happy to be challenged on this, anytime you try and purposely make one technology the everything, you end up with 4 technologies that claim to be the everything, right? And that's sort of the race that we see now, in that like something like Unity Catalog has that promise, but again, it's for the Databricks ecosystem, right? And Gravitino also has that promise, but it's also for the open source ecosystem. And there's a lot of holes there. I think we're going to learn our lesson in that the way that we interact with different tools and technologies isn't through centralization, but is actually through federation and distribution. So can you have a catalog that even if it doesn't contain this specific metadata and these attributes, can it be compatible, and can it then reach or federate towards something else, some other system that does, right? Because there's going to be a different stack that does that anyways. And that's sort of the idea that I would hope, because eventually, no matter what the tool is going to change, whatever catalog we decide is everything is going to eventually become outdated, right? And that was even taking into account that we all probably used HMS at one point, and it's still around, but are people really advocating for it like they used to? So hopefully that answers your question. Yeah. Hi. Yeah. White shirt. Yeah.
I had a question about designing and developing AI-first features.
Mm-hmm.
These things are changing so fast with LLMs.
Yeah.
So what's kind of your and your team's philosophy? Is it like, okay, you got to stay on the leading cutting edge, okay, new MCP standard version ships, we got to get on it? Or is it more like caution, trying to see what shakes out, what stays?
It's hard to say. So I remember reading about MCP and being very excited about it in like early February. Like that was when it was like first announced, and the only people who were covering it were like paid YouTubers, right? And then I decided to ignore it, and then 6 months later, it was everywhere. And that cycle used to be years, and now it's months, and soon it's like going to be weeks and days, right? I think really the technologies that are able to be flexible and account for the fact that it's not going to be the standard and that things will change. Like, can you have a technology, and this is why I think Gravitino does really well, is yes, it can support MCP, but it also is going to have in its back pocket whatever comes after MCP, because it will be something after MCP. And that sort of flexible system that can federate and be able to, you know, work in a more distributed way versus a very rigid, hard to find way is going to be probably what sticks around a little bit more, even if as a useful legacy technology, right? That's sort of the ideas that I have around it. But also, we're a Bay Area startup. We need to raise money. So then maybe that's the real answer.
So I've been thinking about like taking some of the ideas that I've learned and kind of doing like the next evolution of some more general tools, like a more general purpose like prompt templating format. Is there someone I could like pitch some of the tools I'd like to work on to get sponsors by chance? I know it's kind of like a weird question, but
Yeah, maybe reach out to me after. It very much depends on the tool and what the problem statement you see is, but at the very least, if like it's open source, then yeah, we can give you a ton of platforms.
I communicate better over email anyway.
Yeah, fantastic. One more. Yep.
I didn't quite understand the catalog concept from this point of view. Who constructs the catalog? Who populates the catalog? Is it just people, humans, or is it just agents who are in the wild?
That's a great question. Yeah.
If you look at the internet, pre-LLMs, there was a lot of garbage, but a lot of good stuff too. But post-LLM, it's like mostly garbage.
Yeah.
And the problem is, now you look out and look.
Are you talking about shitifications?
Huh?
Shitification?
Well, I don't want to say that, but let's say it's garbage in, garbage out. And so, is this like a human endeavor for the catalog construction?
Ideally not, but it depends on what catalog you're working on, right? So if you're working with a business catalog, like a traditional catalog that most businesses have used, that's been populated by humans. Like that was literally a data steward going in and changing the business glossary. If you're looking at a technical catalog, that inherits from the actual physical devices. So let's say if we take Hadoop or Iceberg, for instance, I am working on an S3 bucket. I decide to store Iceberg tables on that S3 bucket. That Iceberg table, not really that interesting on its own, but it does have like a very specific catalog pointer. I decide to use an IRC, an Iceberg REST catalog. So that's an implementation that then can adhere to the Iceberg REST catalog spec that's been defined by the Iceberg maintainers. And in that Iceberg version. And then what that does is that it guarantees specific information about the physical attributes of those tables. And that can be really interesting. And then what I can do is through a query engine, I can manipulate or I can pull that metadata as required, or I can pad it to another catalog. And so the reason why I go through that story is because, at least from Gravitino's perspective, that's kind of the catalog space that we're in, right? Let's say you're working with Postgres or MySQL. You're very likely using a JDBC catalog to manage those tables, even if it's obscured from most people, because the machine itself has to manage the tables in some way. It needs to store that metadata about the tables themselves in some way. And that information is pretty like hard and true when it comes to like, what partition is this data stored in? Like, what are the values in this column? And what does this look like? What size is it? Things like that. And so for that information, it's very hard to spoof, right? In my opinion, because you're just pulling from the physical source. Where I think it gets a little bit messy is, again, the semantic layer, right? Where you have these humans coming in who are defining these different things. And that piece is sort of out of our scope a little bit, but I would hope that maybe there's a dedicated way, either through like, modeling or third-party tools, or just like a dedicated team into creating the context for that pieces of data that actually makes sense for the system. So again, it's like, do you really blame the tool for having garbage data coming in that has a bunch of null values? Like, yeah, I guess so, but that's also like, whose fault is that really, and is that something that we can really change?
Yeah, I think my stuff is kind of more relevant to his question.
Yeah.
My philosophy has been that like you can't generate like something from nothing and expect ideal results.
Yeah.
So like in my case, dictionary data sets, I would source a lot of that material from like ebooks.
Yeah. I would love to talk to you more about that. I'm going to go to his question though. Yeah.
Extending the previous question from him, at some point during the demo, the agent said that it was looking through the catalogs to identify the relationships. Where are those relationships set up, or how are they set up?
Yeah. So essentially, it just really like analyzed the schemas, and then it said, okay, what are the column names that are similar? What are the keys that are similar, and how would these columns relate to each other from different sources?
That's in the catalog itself?
Yes. Well, the catalog itself is just the registry of other catalogs, but it has all the schema information. It has all the physical and logical data.
But no one actually sets up the relationships?
No, it's inferred by the LLM, yeah.